To solve a trig equation means you need to find the angle that makes the equation true. One way to do this is that you could rewrite it in inverse form. In this case, the inverse form would be sine inverse of square root of 3 over 2 is equal to the angle. I'm going to leave it in the original form. And since we're looking for solutions on the interval 0 to 2 pi, we're looking at all 4 quadrants. So since the answer or the sine value is positive, I first want to identify the quadrants where sine is positive. Sine is positive in the first quadrant and the second quadrant. And I'm going to use triangles here, so I'll draw a triangle in each one of those quadrants. At this point, you can start to fill in the sides that you do know. Since sine is square root of 3 over 2, and sine is equivalent to opposite over hypotenuse, I would write the square root of 3 opposite of the angle, 2 in the hypotenuse. This is one of the special triangles. This means that the other side of the triangle has to be a 1. Or if we're talking about the angle in quadrant 2, it would have to be -1. And now to solve this, we need to find the reference angle for each one of these triangles. Once we find the reference angle, then we can find the actual angle. We can find the reference angle because it's one of the special triangles. So when we have an angle where square root of 3 is on the opposite side, that always means that the angle is 60 degrees, or in radians that would be pi over 3. In this case, pi over 3 is the reference angle, and since one of our answers is in quadrant 1, that's also one of the actual answers. And then to find the other angle, the one in quadrant 2, we would do pi minus the reference angle of pi over 3 to find the actual angle. When working with angles in radian measure, the best thing to do is to get a common denominator. So in this case, I can rewrite it as 3 pi over 3 minus pi over 3, and so the answer is 2 pi over 3. So this particular equation, sine of theta is equal to square root of 3 over 2, has 2 solutions on the interval 0 to 2 pi. And those 2 solutions are pi over 3 and 2 pi over 3. The second part is to identify all of the solutions. So since sine is a periodic function, that means it repeats every 2 pi. And now we want to express our solutions with that concept of periodicity in mind. And so to do that, we would take one of our solutions, in this case, let's start with pi over 3, and we can add 2 pi k, where k is an integer. So that means k could be positive, it could be 1, 2, 3, 4, etc. It could be 0, it could be negatives. And in this case, we're saying that the solution is pi over 3, but you can add or subtract any amount of 2 pi's, essentially, and what you end up with is another solution to the original equation. And the second set of answers will be the same thing, but using the angle 2 pi over 3. So that would be written as 2 pi over 3 plus 2 pi k. And together that represents all the solutions for this equation.